Have you ever heard the expression, resisting temptation? Resisting means to withstand something, and that's what electrical resistors and resistance in an electrical circuit does. In this video, we're going to learn about electrical resistance and resistors. An electric current is the flow of electric charge, composed of negative electrons, through a conductor. It is measured in coulombs per second, also known as amps or amperes. The conductor is made of atoms, joined in a metallic lattice of free electrons. As the current flows through the conductor, the electrons collide with the atoms. Energy is thus transferred, for example, to heat. This explains why a wire with electricity flowing through it often feels warm to the touch. A difference in electrical potential, measured in volts, is needed to propel the electrons through the metallic structure. The voltage measures the amount of energy per coulomb or joules per coulomb. Different conductors will have different metallic structures and so exhibit different resistances in a circuit. A component with a high resistance will need a higher potential difference, or voltage, to move electrons through it compared to one of a lower resistance. George Ohm found a relationship between voltage, current, and resistance in a circuit, which we know as Ohm's law. V equals I times R. R is the resistance, measured in ohms. V is voltage, measured in volts. And I is current, measured in amps. Thus, for a particular wire, if you want to double the current flowing, you need to double the voltage applied. Ohm's law can be displayed in a formula triangle like this. Voltage equals current multiplied by resistance. Current equals voltage divided by resistance. And resistance equals voltage divided by current. Let's try an example. A wire is carrying a current of 5 amps, with a potential difference of 80 volts across it. What's the resistance of the wire? Pause the video for a moment and have a go. We should use the equation R equals V over I, which equals 80 volts over 5 amps, which equals 16 ohms. Remember, resistance is measured in ohms, and the symbol for this is omega. Let's try 2 more examples. Calculate the resistance of the lamp in this circuit. Pause the video while you work out the answers. Calculate the voltage or potential difference across the lamp. Did you get them right? You also need to know that the resistance of a conductor increases as its temperature increases. This is because temperature is a measure of the vibration of the atoms within the conductor. As the atoms vibrate more, so the electrons collide more often, making it more difficult for the electrons to flow and so increasing the resistance. Thus, the resistance of an old-fashioned filament bulb increases as the filament gets hotter and hotter. So that's how resistance happens in a circuit and how it can be calculated.